Hi everyone, my name is Jinbo Ma and my major is machine learning and data science. So today I'm gonna show you the stress detection using wearable device data project update. So first one, let's review the motivation and related work. For the motivations, as we know, the stress significance impact like the physical and medical health, like it can make a lot of our body's problem like accuracy, heart diseases, kind of that. So I think if we know that since earlier, like if you have this kind of things, you must have the signal from your body. So if we know that earlier, we can stop this bad things happen. So for the related work, there have a lot of research in internet. So I found one is called WESAD dataset. For this one, they use a lot of like physical signals such as EDA and HRV for the stress detection. So for this one, for my study, I'm gonna use WESAD dataset for my research. For the project goal and the completed task, so for the specific goals, I detected the stress and the baseline I calculate I get detect some of the data sets from here and there I have the stress and baseline there for that. So I'm gonna use the training model, kind of like the random forester and SVM. So the completed test, the first one I loaded and cleaned the data from the WSAD, like the Impacta and RISC Binban, kind of like EDA, IBL, ACC, ECG, EDA, RESP kind of like data over here. For the this is for this one is my Excel it's my Excel. I add a screenshot from my Excel. So this is a lot of different data I already cleaned over here. And I take a screenshot, show you over here. And I also have the down simulate the data and make it easier to work with. And I also calculate the HRV filters like RM, SSD, SDNN, PNN50 from the IBL data. So then I clean and merge the dataset with expected filters. And I also trained like two modules like SVM and the random filter like I said before. So the initial module training, so for this one, I have two figures in the right side. So as you know, I use the random forester and SVM uh, to this research. So as you can see, there I have two different figures. So the first one is random forester confusion matrix, and the next is SVM confusion matrix. So for the first one, so the random forester, it achieves the balance, but the lower accuracy. As you can see, for the stress and baseline is almost like equal. But it's actually not have a much higher accuracy. For the SVM confusion matrix, it looks good, but it's especially in stress predictions, it's better than baseline. For the result, it's over here. For the module accuracy, the random forester is 50%, and the SVM is 44.12%. Yeah, this actually, but yeah, as you know, it's looks low, but I'm gonna train it more and improve it. For the data visualization and analyst, so as you can see, there is two figures. The first one, the we can easily to see that the stress is higher than baseline, but there is also have some of overlap significance. So it means the EDA alone is not enough to detect the stress. So let's go to the next. So this is average RMSSD figures. So as we can easily to see that the baseline is higher than stress. So actually, this match with the medical studies. So when people are stressed, the heart rate variable goes down. So I think this one is good. And there is also have two figures. The first one is the HRV figures distribution. As we can easily say that for the RMSSD by label, and the stress is higher than baseline. For the SDNN, it's almost equal, but if we see that clear, we can see that the baseline is higher to stress. For the PNN50, we can easily to see that the stress is higher than baseline. So So all of them so maybe the HRV is higher than during the stress in this data. So maybe so this not expect. I think the reason is maybe we use the fake label. So let's go to the next. There have two figures. Is first one is RMSSD comparison, and the second is SDN comparison. So the first one, we can easily see that baseline is 35 and the stress is 28. And for SSDNN, so the baseline is 55, the stress is 48. So I think this tell us the HRV filters are useful for stress detection and maybe better than EDA alone. For the limitation and next steps. So maybe as you know, there is a lot of limitations in my studies. So the first one, maybe I use a small sample size and the limitation diversity. So maybe the study size is not enough large. So and the second one is I think the different people have different reaction during the stress, and the last one is the EDA signals shows higher overlap between the stress and the baseline. So this is a kind of three limitations over here. So for the next step, so the first one, I'm gonna use a real label over here. Real label maybe can get the more good the result. And the second one, I'm gonna use more filters like HRV or something else. And maybe I'm gonna improve my module accuracy, or use maybe I'm gonna use different modules like deep learning module, kind of like LSTM or something else. Yeah, this is what I did in the next step. I'm gonna make my research better. Thank you for listening. This is my update project.